Today is going to be about map and compass, route finding, orienteering. That's how I call it, map, compass, route finding, orienteering. I never call it navigation because navigation normally is used in streams, water streams and air. That's why it's called navy. So everybody uses navigation nowadays, even in the Netherlands. I'm old school, so I'll still using the words orienteering, map, compass, route finding, not navigation. Also, when you go in France, you see the sign Navigation interdit. It doesn't mean you can't use your compass over there, it just means you can't use the water with your boat.
So we're going to talk about what we're going to use. Well, we're going to use different kinds of maps, of course. Different scales, different maps. If you got my book, it's handy. Sorry, it's not in English yet. Then, of course, we're going to use compasses, different kinds. We're going to use the protractor. I don't think you can find this one in Canada though, but it's really handy. Some permanent markers with a thin point, Sharpies. Of course, something to write on. And some bigger stuff, so it's a bit more clear when I explain it. I'm not going to carry those around in the bush.
First, we're going to talk about maps. Which information is on a map and how you can interpret that information. Because that might be the most important thing about orienteering, using your map and knowing how to use it. So at first, this is a Canadian map. And this is a French map. And the first thing you do when you take a map, you go and look on the information which is on there. And it's really important to really go through it. So over here, there's a lot of information, but also on the sides and often on the bottom of the map. Read that first so you know what kind of map you got. Then there is this, and to be honest, I don't know the word in English. It's on every good map there is like a legenda, we call it in Dutch, so it explains all the different colors and symbols on the map. Normally it's like almost the same all over the world, at least where I've been. It's not all over the world, but you gotta know what the colors mean and what the symbols mean, because otherwise you don't want to understand your map. So first thing to do is check that out. So as you might know, you have different colors, and different colors say different stuff. So if you got like the dark green, it's forest, light green is fields, white is mostly farmland in the Netherlands, and I don't mean grass, but I mean like crops. Then we got blue, which is water, and different colors in the roads, stuff like that. Symbols for churches, peaks. There are even symbols for different kind of forest. Okay, take a close look at the maps now. So here we got like a map from my area in the Netherlands, standard topographical map. This is water, this is forest, this is field, these are crops, and main roads are red, secondary roads are yellowish, and dirt roads are white. And really small trails are these. And you got like a pinkish color, which is marsh, moor, heide in Dutch. Look at the French map, same colors, almost all the same symbols as well. And then we look at a map from Canada, from the Rockies. Less information on there, or at least there's less stuff to put on the map. Forest, above tree line, glaciers,
one main road, which is the Icefields Parkway, by the way, on this map.
The next thing you want to know is what is the scale of your map, and that means 1 centimeter on the map is what distance in real life when you're out there in the bush or in the fields or in the mountains, whatever. Okay, you got, well, the different scales. In Europe, we mostly use 1 on 25,000. So 1 on 25,000. Which means that 1 centimeter on the map is 25,000 centimeters in real time. Which means that 1 centimeter is 250 meters. 1 millimeter is 25. This is the scale we mostly use in all of Europe. Like the French map is 1 in 25,000, and so our most map I use in the countries I go to. In Canada, that's different. Canada's a big country. Imagine you have to make all those maps on 1 in 25,000. So what did they choose for? They choose for 1 in 50,000. 1 centimeter is 50,000 centimeter in real time. Is 1 centimeter is 500 meters. 1 millimeter is 50 meters. Another scale sometimes used is 1 on 100,000. Same calculation. One centimeter is 1,000 meters, 1 millimeter is 100 meters. I always say you can't go more exact than half a millimeter. And that's already hard, but half a millimeter. So here you can go exact as 12.5 meters, 25 meters, 50 meters to put your dot, your checkpoint, or how you want to call it. Sometimes in orienteering races we use different scales, like 1 on 10,000, sometimes 1 on 5,000. So here it's 1 centimeter is 100 meters, 1 millimeter, 10 meters, and here is 1 centimeter, 50 meters, 1 millimeter, 5 meters. So you can be much more accurate or exact. Accurate is the better English word, I guess. On a map like this than on a map like this. That's kind of obvious. But while hiking and with most courses I do, I'll have a 1 on 25,000 or 1 on 50,000 map. Although I also have maps from Blue Lake area, orienteering style on 1 on, I think it's 1 on 10,000, maybe even 1 on 5, doesn't matter. So you gotta know your scale, really important.
So that's what it looks like. This is a 1 on 50,000 map. And let's check it out. Yeah, that's where I live. Then we go to the 1 on 25,000 map. More information. Easier to work with. And this is the 1 on 10,000 map. Same spot. So you got the same size of map, but with a much smaller area. So this one is half the size of this map, and this one is calculate. Okay, less than half size of this map. Much easier. 1 on 50,000, 1 on 25,000, 1 on 10,000. Of course, when you got a map, normally on the map itself, it tells you the scale. Like here it is, 125,000 for this French map, and here is 150,000 for that nice Canadian map. Okay, more often, maybe sometimes I'll do it. I give my students maps, and those are copies, and so it's not the whole map, just parts of it. And then they always ask somebody else, what is the scale? Okay, you don't have to ask because you can see it yourself. Every map normally is divided by quarters, not quarters, like squares. And each square is 1 kilometer. The sides are 1 kilometer. So if you measure a one side of the square, maybe both sides, it's easy to calculate because this one is 4 centimeters, which means divide a kilometer by 4, that's 250. So this one is 1 on 25,000. And here it's 2 centimeters, which means divided by 2, 1 kilometer is 500. So this side is 1 on 50,000. This map scale is 1 on 50,000. Sometimes with bigger maps, which is smaller scale, like 1 on 250,000, they don't divide the map into squares from 1 kilometer, but 2 kilometers. Okay, you gotta check that out. You can always check the numbers. If it's like 64 going to 65, there's one number between, so that means it's 1 kilometer. When it would be like 64 to 66, then the square is 2 kilometers. Okay, another important thing. You got a map and you have it like this, then the top of the map is true north. So map north, true north. Then the other side is south. And this is east and this is west. Sometimes they make a map not like that because they want to like fit an area in there, but then there's a sign on there with punch north. I don't know the word in English. We call it windroos in Dutch. So you will have a sign. This is really hard to work with. I always get like, what the hell happened? Where did north go? But still, sometimes it happens, but normal, the good maps, the orienteering maps, the topographic maps, this side, upside is north. Okay, now you see people running around in the bush with their map, and they change it. So they are we're going west, I'm going to change my map like that. You can do that, you're fine. If you want to do it, it's fine. I never do it. I always keep my map in the same way. So with north away from me, and I put myself on the map, which sounds a bit weird, but I kind of see myself walking on there. Yeah, I did take my pills. I see myself walking on there, and I just turn right, turn left, go east, and that's for me the most easiest way to orienteer, to find my route in the terrain. Put myself on there, and then I know the directions. So I split the map in 4, and I know, okay, that should be west or east, and that should be the other side. That's how I do it. But you can do whatever you like, as long as you don't get lost and stay alive. Another thing you want to know is how old is the map, because well, the terrain doesn't change, but sometimes, like here in where I live, farmers change. So one day it was crops and the other year it's field, or a total forest has disappeared. So signs in the terrain can change. So be aware of that. If you get an old map, don't count on it that it's always correct. And even with a new map, don't count on it it's always correct. Something that doesn't change are these little lines with a number. This one says 30. those are altitude lines. So this over here is 30 meters. So this is the Netherlands. Not a lot of altitude lines, but when we go to the map of France, you see a lot of them. And we switch to the map of Canada. Quite a few. Well, the closer those lines get, the steeper the terrain. You might want to know that when you're finding your route through terrain. Next thing you want to know is the difference between the lines. So how much are they apart? Those are called contour intervals, and this one is 40 meters. Between each line there's a 40 meters difference. That might change with every map, because you might imagine that over here that's not such a big problem to do a 2.5 meter contour interval. But if you got a lot of mountains, you don't see anything else on the map but those lines. So check it out. What's the difference between each line? What's the space, the distance between each line? So this is how it looks like without all the other information. So as you can see, it is like a hill, because this number is higher than that number. And as you also could see is that this side is steeper than the other side. Now, if you can't find your contour interval on the map, you could always count the lines between each number. So there's 5, so contour interval would be 100 meters or feet. Check your map if it's in feet or meters. So this one is for the highest point. That's nothing to do with the interval between the lines. And this is kind of really easy to see that this is like a mountain. You can approach from different sides, but sometimes it's different. Sometimes you just have the lines like with a ridge, and not everything is on the map. So now you gotta know which is up and which is down. Well, here you can see the 2 numbers, so that's easy. So this is downhill, this is uphill. But also, if you have only one number and you approach it from this side, you go on top of the number, which means you go down. So if you go from this side, you go to the bottom of the number, you know you're going up. Check it on a map next time and you'll see it. So, okay, this is downhill, this is uphill. Also with this number not here, I still would know that that is downhill and that is uphill. So that was the intro on maps. Now we'll go further with our compass, and after that compass and map, of course. So we got different kind of compasses. The simple ones, these. We call it plaatkompas in Dutch. Then we got a spiegelkompas. I don't know the word in English, sorry about that, but with a mirror on there. And I'll explain why you might want to choose for this one. And then I also have a orienteering compass, which could be around my wrist to keep track of the of the bearing while using a map. So I carry it like this, and then I always have my bearing with me, the direction. I'm not going to use this one with my video. We're going to use the other 2, so these 2 we're going to use. Okay, first, a few important things.
We got our compass needle. I think the most important one, which normally the red part points north and the white part points south. Why do I say normally? I'll show you later. Then we got the gradenboog. I think it's called protractor. This one, you can turn it. And then we got our direction. With this compass, this is your go-to direction. So not the needle, but this. And with this one, this is your go-to direction. This. Important. Sometimes you got like centimeters on there, sometimes more stuff, but we're gonna use only this, and the compass needle. So like I said, normally the red part of the compass needle pointed north. This one doesn't do shit anymore, so you don't want to use that one. And I do have a compass, but I can't find it. It has a 180 degrees mistake, so the red one points south. So always check that before you start, if your compass is still working like it should be.
So the compass needle points north, the wet one, so that's north. When using your compass, be aware that your needle works with the magnetic field, so there's stuff that can influence your needle or take it off course, like another compass, or electronics often do it as well. You see? Oh. And maybe some iron in the surface, like the screws or bolts in this table. So be aware of that you use it without something that takes care of the bearing of the needle. So take a big one. It's just a bit easier to do. So switch it, the needle goes that way. Now we got our compass on north. So I want to go north, this is the bearing. And those numbers are more exact than the letters. So north is 0 at 360 degrees, east is 90, south is 180, and west is 270. And then of course you got northwest, southwest, north, northeast, etc., etc. But normally we use the numbers, not the letters. Although when I say go north, I do use north, south, east, west, but not the other ones. And of course it's not often that you go like straight north. Might be like 355 degrees, 385, or 02 degrees, whatever. So this one is really important to use.
So how do we find our direction using our compass? I'm going to use this one because it's easier for you guys to see. Imagine you have to go, let's say 110 degrees. You got to walk 110 degrees for a distance like 1 kilometer, and you want to put it on your compass. So the first thing you do is you turn your protractor until it says 110 over here. Now you're going to turn your compass so that the red arrow is right between, mostly it's two lines, in this case it's up. And now I know when I keep it that way, I gotta go that way.
walk this way. Hop, go. Show you with a real compass now. Normally you gotta keep those horizontal, of course, but I'm gonna put it on 110 degrees. Got it on 110 degrees. Now I'm gonna turn my compass so the lines are in there, and I gotta go that way. Again, turn this one to 110 degrees. Now I'm going to turn my compass until it matches the arrow, and I'm going to walk that way for a certain distance. Sometimes you want to put your map on the north. Mostly to check if you're still in the same area, like you look on the right, there's a lake, you look on the left, there is forest, in front of you there's a mountain range, something like that. So what do? First of all, you turn your compass with north on your moving direction. Oh, I already put it like almost straight. Then you put it in the corner, your compass, and you move your map till it's straight, and now your map is pointed exactly north. Do it again. Up, north, south, in the corner of the map. This is true north. Not talking declination yet. Turn the map. And now my map is pointing north, magnetic north. So now I'm in the field and I want to calculate what the bearing is from my start. From my start, which is over here, to my next checkpoint, F finish. So I want to know what my bearing is. What do I do? And which way should I walk? So the first thing I do is I put my compass in line. Now I'm going to turn the protractor, the gradenboog, that north on this one is pointing at the top of the map. Don't look at the north, how do you call it? Pointer, needle. The needle not important, which is moving, by the way. So there should be iron around. But okay. So I'm going to turn it. This one I'm going to turn. So I turn it so like the lines inside the compass are linear with the lines on the map, which point to true north. Like I said, upside of the map is north. So now I can read over here what are degrees, and those are 70. It's 70 degrees. So I'm going to walk 70 degrees later on, but I gotta have the distance as well, of course. Okay, now I measure it, and it's 42 millimeters, which means, 4 centimeter is 1K. So it's 1 kilometer and 2 millimeters, which is 50 meters. So that's it, 7 degrees, 1050 meters to go. So now I gotta put that one on 70 degrees. So I put it on 70 degrees. Now I gotta turn my compass until it's in line. And it's that direction for 1K and 50 meters. If I want to go in a straight line. Of course, you're going to use roads and anything else, but if you have to go in a straight line, that's it. So again, turn your compass until it fits, and that is the way you have to go. Okay, so now we have a point on the map, which was, and then we have to calculate. So now I'm going to do it the other way around. I'll get a bearing and a distance, and I'm going to mark it on my map. So the points are not on my map yet, so I can calculate. No, now I got to put them there myself. It's not that hard. So I put my compass on 140 degrees, and now I gotta put my compass in line with my starting point, and I'm gonna turn my compass until, don't look at the compass needle, the lines in the compass correspondent are in line with the lines on my map. So this is the direction, that's for sure. What I do now is I mark a little short line, the direction. And now I can take my compass away. Of course you can mark it direct when you have a centimeter on your compass, but I prefer this way. So now I'm gonna check, put my lineal in line, and now it's 1500 meters is 6 centimeters. So my dot's gonna be there, 6 centimeters. There it is. Of course, normally he would choose the roads to go there. Might be the fastest way, but okay, in different terrain you can't always do it. The technique stays the same. So what do I do now? I'll put my compass on that 140 degrees. My compass is 140 degrees. Gotta turn it now, and then now I use my mirror compass, because then I can explain why it's so easy. So this is my direction. Fuck, there's a lake. Holy, there's a lake. Okay, what I'm gonna do now is I'm gonna aim, and with my mirror I can check that my needle is still in line, and then I see where I have to go, and I can point at like a tree, that tree on the other side, because there's a lake. So I can walk around the lake, go to that tree, and do my new bearing on. So you can check in your mirror, even when you go further, if your compass needle is still in line, so you can aim better. Went to the shades for one moment so you could see. And if you want to do it really exact, because I'm going around the lake, and that lake is 5 millimeters, so that means 125 meters, then it's still 1375 meters from the other side of the lake.
So those were the basics on compass. So we have done map and we've done compass. And okay, remember, this is all like theory. You can know the tricks before you can go in the field. But of course in the field, it's the real deal. And it's the real learning. But still, you gotta know these tricks. So when you come to Canada, guys, know these tricks, otherwise ask me while there. Okay, next thing we're gonna do. This is going to be fun. We're going to talk about the protractor, and I'm kind of surprised I found it right away. The thing you always lose. Het ding dat je altijd kwijtraakt. That's how I call it. So if you found one, buy at least 2 or maybe even 5 or 10. Because you're gonna lose these and they're really handy. We're gonna talk about grid systems, which you're gonna need for the other lesson on GPS as well. So it works both ways. So the protractor, oftewel de kaarthoekmeter. So how does it work? I have enlarged the grid system on this map over here. We're using Dutch grid system, but the way of calculating is totally same with UTM UPS grid systems, which we're going to use on our GPS as well, Dutch grid or UTM UPS or another grid system. We never use geographical grid system. My Canadian mentor back in 2007 told me only fools and Navy use that system, so we don't. So yeah, because it's a different ballgame. We're going to talk about the grid systems we got in Canada, in most of Europe, luckily. So I'm going to enlarge, but this is the map. In short, the grid system. So what do we have? We have numbers. We have 495, 460, 461, 462. Those are the latitude lines. And then we got the longitude lines. 242, 243, 244, 245. Those are mostly on both sides on the map, like on the east and on the west side, or west and east side, and on the north and on the south side. So you can easily find them. So when I want to point out a square, where you're at, and I want to point out this square, the center one, I would tell somebody, okay, you're in square 243 by 460, because it goes up to 461, so 460 is not on this side but on that side. 243 is on that side and not on that side. So center one is 243 by 460. Don't change those numbers around. Always the top numbers first and the side numbers second. So here they're quite different, but sometimes they're really close and you get mixed up, and on your GPS does the same thing. So first longitude, then latitude, that order. Okay. Every square is divided into 100 times 100, not a square, so that's all. So you can go more exact with the numbers marked here. Here, 68 and 50. When you got a GPS coordinate, there's going to be an extra one for the exact meters. But over in this system it doesn't work. You can't use it on a map because it's too exact. But with a GPS there's another number behind there. So if you use a GPS grid system for your map, lose the last number. So I want to find my checkpoint, which is sent to me, and it's 243 by 68, 460 by 50. What do? I'll take my protractor, and there's 2 lines, normally, two different scales, one on 25,000 and one on 50,000. Normally they have both. This is one on 25,000, so you can see that these fit in the squares. See, one side and the other side. Kinda. If I want to find 68 by 50, 243, 68, 460, 50, I start with 243 plus 68. So I'm going to read over here. And I'm going to pull till it says 68 here. So this is how far I have to be in that square. Now I gotta check how far up, which is 50. So I keep these on 68 over here, and here I'm gonna read to 50. So that is the point with this coordinate, So this coordinate is that exact point. Okay, now I'm going to show you a real map. 243, this is this one, by 60, so I'm in this square. Now I'm going to get my protractor. And I'm going to move it around till it's on 68, 50 up. That's the corner where it should be. So over here I read 68 and over here I read 50. 243, 260. Don't mix up those numbers. It's often that they put the last two numbers with the wrong first. Check it out. Of course, it also works the other way around. Let's say I'm gonna do another one, this one. Just pull it here up. I want to know what is the coordinate of that point. So I can put that in my GPS or anything else. I'm going to do it a different way around. So this is going to be 243 or same. 243, the square, by 459. 459. Now I'm going to put it on there like this. And I'm going to read here 65, 243, 65. And over here, that's about, well, let's say 78. So this is my coordinate for that point.
So that was the coordinate system, and like I said, with Canadian maps it's the same. You got these numbers, and it's just a different grid system, but it works the same. So now one other fun part you can do with your kaarthoekmeter, the thing you're always gonna lose, protractor, het ding dat je altijd kwijtraakt. You can do your bearings as well with this system over here. The gradenboog, with the same one. Check from, we're gonna do this to that like we did before with our compass. I center the circle, there's a cross in there, and now make sure that all these lines are in line. And now I can put my lineal or something else over there, and I can read what the bearing is and put that one on my compass.